Does anybody want to have a big bowl of molecular gastronomy this morning? Does that sound good? Molecular gastronomy is, what we're doing is we're using science to help us cook. So if there's a better way to do something, I want to know that better way and I want to do it. You know, my dad, when he was a cook, you know, he had 12 people working in the kitchen. They all had various things. One person would come in and slice onions, and one person would stew meat and do different various prep items. Kitchens these days are a lot different. You have 4 or 5 people doing the same job as 12, 14 people. And we're doing a lot more crazy stuff. We're utilizing thermal circulators and liquid nitrogen and all of these fun processes to help us cook and come up with new textures. So that's pretty much what I do now. I have a company called The Inventing Room. If you guys see all the Willy Wonka stuff, it's on purpose. The Inventing Room is the room where you go in and get really big and purple and they have to drain you. So we want to inspire whimsical and fun and just a little bit different. So primarily what I do now is I travel around and I make stuff come out of people's noses. And I'll demonstrate that a little bit later. But we make drinks and ice cream and different kind of textures for people. So, but that's a little background on myself. So when they first called me up to do a little demonstration today, and they gave me the topic, bravery, I thought to myself, that's pretty much perfect for what I do because my whole career has been a constant bravery ball rolling and rolling and rolling. So bravery wasn't something that was given to you, it's something that's inside. And I think that's a huge thing is we all have it, we just need to kind of harness it and get to it sometimes. So I'm gonna pick up my phone now because I got a good quote here I wrote for you guys. Bravery for a chef happens every time we put a dish out. So what I mean by that is I work in a very unique field. It's about instant gratification. If the gentleman was here that was making your croissants today, he would probably be watching everybody, seeing if you guys like the croissants. You know, I spend a lot of my time when I worked at a restaurant in the dish area. And what I would do is when the waiters would go pick up all the plates that were used, I would see what food was left on the plate. And that really gave me an idea of if the people liked that dish or not. Because when you go and talk to somebody, they blow a lot of hot air up your ass sometimes. Excuse my language. The steak was great. The vegetables were cooked perfectly. I do the same thing. I really don't want to have confrontations with the chef, so I just tell them it was great, and then maybe that I don't come back to that same place. But I can tell what you left on a plate, if you like that dish or not, or if it worked. And it's a constant evolution for me. I never really settle on, this is the perfect dish. And by the way, it's impossible to make the perfect dish. We all grew up with different tastes. We all grew up with different moms. My mom was a shake and baker. Your mom might have been a griller. So we all come up with different flavors and how we like food. So the perfect dish, to strive to make the perfect dish for a person is pretty much impossible. Except I have a theory. My theory is I want to build a scanner that when you walk into my restaurant, I would scan your tongue. And with that, I could learn how many taste buds you have. If you're a super taster, if you're a medium taster, if you're a non-taster. If you could taste sour, if you could taste sweet, if you like more salt, if you like less salt. So imagine somebody scanning your tongue and then having a recipe book with numbers associated with how your tongue was reactive towards different things that you ate. So there, in that instance, I believe that you could come almost pretty much close to be creating a perfect meal because you're really dialing into those people's exact taste buds. So I'm gonna try to turn this. It was that easy. So I did a lot of cooking. It was a lot of fun. I got to a point, which we all do, where it's like, do I really want to do this anymore? Do I want to start something different? I hit my wall, like I said, at the hotel. Met all these people. I came back to the hotel and I started ordering all this crazy stuff. So when I say crazy stuff, we're talking about all this stuff that's been available in the processing industry for the last 30 years that is now being translated, and now gourmet chefs are getting their hands on it. For example, there's a product called VersaWhip. VersaWhip's used in Wonder Bread to make it really, really wondery. It's also used in marshmallows to make them really fluffily. But when I get a hold of it, I can take it and mix it with balsamic vinegar and keep whipping it into a foam. And I can take that foam and put it on top of a salad, and then take a blowtorch and hit that foam with the blowtorch and brown it, and it'll keep its shape. It's pretty wicked and pretty weird and pretty fun. But it's a texture that we were not able to do 20 years ago. I guarantee you my dad was never sitting in a walk-in going, you know, I'm gonna make some whipped, burnt balsamic foam today. It just didn't happen in his time, and that's why it's exciting for us now that we're able to get our hands on this stuff. With all of these things comes more responsibility, and I unfortunately have had to learn a lot of lessons playing with chemicals and playing with different things. And I'll give you a couple quick examples. I'm on the watch list for the Denver hazmat team. When I first started catering, I had a Honda Civic, which is not the best catering vehicle. It's a two-door, actually. So I would have to load my coolers in there and all of my stuff. And I had a couple containers with all these vials of white powder, xanthan gum and carrageenans and agar and all this stuff that was helping me cook. So in the back, I have, you know, 3 of these big, huge containers with all these white vials in it, okay? I've got this sitting back there. I've got a tank of liquid nitrogen sitting next to me. And I get pulled over. So the policeman walks up to me, and I wish I would have had a camera at his face when he saw all of this stuff in my car. So he tells me to exit the vehicle. They're gonna do a search, of course. So I'm back sitting in his car, and I watch another squad car pull up, and the third squad car pull up, and the fire truck pull up, and the hazmat truck pull up. And the 4th police officer that pulled up had eaten in my restaurant that week. And he was the only reason that I probably did not go to jail today, because he literally went up and said, "This guy's legit. You don't need to worry about this guy." So that was the first ticket that I received. So not 3 weeks later, I get done catering a party. I've got my liquid nitrogen tank sitting on my chair of my Honda Civic, parked at my house. 3:30 in the morning, a big rumble at my door. So I walk out, and the fire department is right outside of my house. Somebody had rear-ended my car. The liquid nitrogen tank was full. It had spilled over. Liquid nitrogen expands at 2,000 times its volume per second. So it blew all of my windows out of my car. And you can imagine the sound that happened in my neighborhood. So same gentleman that had, same hazmat team that was there before. Gentleman knew my name. He was really, really nice. They actually dressed up in all of the garb this time. So that's my experiences with chemicals and, you know, all of that kind of fun stuff that goes with it. So knives. Bravery. I have been very, very fortunate. We taped a Food Network show about 2 years ago. We had a cart that we were doing the ice cream and stuff off of. So it plays on the Food Network, and it's really cool because it starts playing in different portions all over the world. So I'll wake up and there'll be like a guy from India, you know, a guy from Pakistan. We want you to come over and do some events. I didn't answer the guy from Pakistan yet, but you know, knives are a big thing that we have to do. And, you know, bravery for me is doing these events overseas or in the United States and packing all of this stuff in bags and actually checking them on the plane. I've been pulled off a plane twice just because, you know, they didn't know what was in my bags because I carry superconductors and all this crazy stuff. So, but knives are the tools of a chef when we first get going. You know, you can tell in culinary school somebody that's wielded a knife for a little bit and somebody that's, you know, obviously going to stab themselves for a little while till they get used to it. But knives are, you know, they're such a fundamental thing for what we do. And it's a specialized field. I have a friend right now that actually forges knives. So he has a big kiln, and he goes every day, and he's learning like how to do the old Japanese knives where they fold them like 2,500 times and crazy stuff like that. So, big part of our trade. A lot of stuff that we do is associated with stabbing and cutting, fire. So fire is obviously what I started out with. I didn't have liquid nitrogen or any of this stuff. So that's how I was, brought up, is cooking and, sauteing and grilling and all that kind of stuff. There's a thing called asbestos hands. When you work in the industry a lot of times, you're constantly grabbing stuff that you shouldn't be grabbing. And fire has a lot to do with that, because we're grabbing pans and really just searing the crap out of our hands to the point where we can't feel anything. So I would work with chefs a lot of times where we wouldn't even have towels on the line anymore. We would actually just open the oven and we could grab pans with our hands and take them out and flip food on the grill and stuff like that. So keep working at it, and you can have no feeling left like myself. And this is another reason why I don't have any feeling left in my hands, is liquid nitrogen. So that's what we're going to do a little bit of the demo about today. Some of you are wondering why we have some Cheetos up here. We're going to do some liquid nitrogen Cheetos. It's kind of a fun texture and kind of explains a little bit. But nitrogen is the ingredient that I have leveled, or, what am I trying to say? Gone to the most. It's a liquid that's minus 320 degrees. So if you think about it, it's about the same temperature as space. And if you want to talk about bravery, the first time I used liquid nitrogen, we got it at the hotel. And it's kind of fun to do that. So we got it at the hotel, and I had no idea about liquid nitrogen. It freezes stuff really, really cold. That's all that I knew about it. So we started dropping, Twinkies in it and Ho-Hos and, everything that we could possibly do to see what it would do in it. So I thought, I'm just going to take like a normal glass and pour liquid nitrogen into it. So I poured liquid nitrogen into the glass and I sat it there. And I'll never forget the noise that it started to make. It was like a crackling, like, icebergs falling and starting to come down on your head. Well, I went like this, and by the time I reached like this, that glass exploded into my back. And I had to have 3 of my line cooks actually picking glass out of my back because of it. So I learned a valuable lesson that day. The first of which is you have to have a tempered glass when you use liquid nitrogen. So we actually do a texture called the world's coldest beer. So we'll take a pint glass and fill it up with liquid nitrogen. We let it evaporate off, and then we pour a beer in there. And what happens is it brings it to about 32 degrees, the freezing point of beer. So it's the coldest, most awesome way to have a beer. But the glass has to be tempered. So a very, very important lesson that I learned there. So I'm going to start cooling this little thing right here. So this is a superconductor. So this started out about this thick. It's molybdenum, titanium, 10 other rare earth metals that I'm going to just butcher if I try to say them. It's put it in a superheated kiln. So we're talking about 4,000 degrees. It's put under pressure. So it's just push, 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 push. And we end up with this little thing that we call a puck. So I've got 2 of these in here. So this is a styrofoam container. And what's really cool is styrofoam is the best conductor for liquid nitrogen, which is kind of weird to think about, but it holds it in really well. So what I'm going to do is I'm just going to start pouring liquid nitrogen on these conductors. So we have superconductors, we have liquid nitrogen, we have air conditioning, we have skyscrapers, we have all of this really cool stuff because we've been trying to get colder and colder and colder. We've been trying to get to absolute zero. In 1996 in Boulder, just up the road, they got to 1/1,000,000th of a degree of absolute zero. And that's pretty close, but they think to get to absolute zero, you might have to have a reaction as big as the Big Bang. So that's maybe where absolute zero was, the only place where it happened was at the Big Bang. So in the 1880s, we had all these crazy scientists going, all right, let's liquefy some gases. I don't know where or how or why they got to this point, but there was a race to liquefy nitrogen. And you have to think about the technology and stuff that they were using in the 1880s. It was all glass. It was all non-tempered glass. So all these people are trying to liquefy gases in these, these contraptions that were definitely not built for it. So you're having the scientists stand back and all of their lab assistants dying trying to liquefy gases. I think I read there was like 40 or 45 people that died in this one lab trying to liquefy liquid nitrogen. So the superconductor's all cool in there. And then we have a rare earth magnet. So this is a magnet kind of on steroids. So I'm just going to kind of push down in here. And I'm going to find the field. And when I do, this is actually floating in midair. So I'll spin it a little bit. So the story behind the superconductor is I hate chocolate fountains. I hate chocolate fountains. So I was sitting at the hotel and we kept getting orders for this chocolate fountain coming in, and I was like, we got to stop doing this. So I thought to myself, we got to do this other really, really cool, fun presentation. So I thought to myself, wouldn't it be cool if you walked into my restaurant and the food was actually floating in front of you when you sat down? So I thought back to 6th grade science, because that's pretty much what I do all the time now. And I thought about superconductors and a gas called sulfur hexafluoride. Sulfur hexafluoride has very large molecules. So if you put it in an aquarium tank, you can actually get textures that are lighter than air to sit on top of those molecules, which is pretty cool. But it's the worst greenhouse gas, and it's really, really expensive. So that was out. So superconductors. So I started emailing all these scientists around the United States. I was like, yeah, I got this really cool idea. I want to float some food. I'm a chef. I emailed like 82 people, and I didn't get one response back from anybody. I mean, I don't know if my email wasn't working or what the problem was. So then I went to the big boys. I went to a place called Thevia Labs. So they're based out of Germany. And they build the superconducting trains in Japan. So they build huge, massive superconductors and all of this great stuff. So I just called the CEO up, and I'm like, I'm in Westminster, Colorado, not even in like Denver or any. And I'm like, I really want to float food. Could you help me out? And just silence on the phone. And then like 20 seconds later, he starts laughing. And he's like, that's a really, really cool idea. I was like, yeah. And he's like, send me some pictures, tell me what you're thinking about, we'll start developing this stuff. So I go to bed and I wake up the next morning and I go to my email box, and he had sent me a picture of when they opened the superconducting panes in Japan, they made a superconductor and a magnet large enough to go around a sumo wrestler. And they floated a sumo wrestler for the opening of this event. So once I got that picture, I was like, we'll definitely be able to do something, because I don't want to float a wrestler yet. That's a great idea. So we have all these different rings and different magnets and stuff like that. So this is a ring magnet. So I just got to kind of find the force. And then we can take an egg, and it'll float for us. It always doesn't go flat when I'm in front of a bunch of people. So we make chocolate truffles now, and we set out like 10 of these, and we'll do weddings and stuff, and people will spin chocolate truffles, and people can come up and get chocolate truffles off of a floating plate. So chocolate fountain, I win. So that's a little bit of what I do. My most passionate thing that I get to do is we've done a school science program for the last 9 years. And what we do is we go in and we show kids how food and science are so closely related. So one question that I like to ask that I want to know if anybody knows the answer is, what does photosynthesis and pop rocks have in common? Oh, thank you. Raise your hand. Nice. So as a food geek, I built a pop rock making machine at home. So it's a vacuum chamber that we put sugar that's cooked to about 330 degrees in, and then we inject carbon dioxide into it. So imagine bacon Pop Rocks, or olive oil Pop Rocks, or all these crazy kind of fun new textures that we can put on stuff. So that's absolutely my passion, because the kids, they're so open, they'll try new things, but they'll also come up with great, questions and stuff like that. The girls always have amazing questions, how are we going to use this for science, and what are we going to do down the road and stuff like that. The boys ask, how do we blow stuff up with this? It's totally inevitable. See, the egg just dropped. So, I tell them that, nitrogen in the future, imagine having an air conditioning unit outside of your house, but it's a liquid nitrogen unit. We could use it to cool our house's refrigeration. All IQF fruit and vegetables that you buy in the supermarket, that's individually quick frozen. So a lot of people have gardens now. We could take tomatoes, you put them in liquid nitrogen, you put them in your freezer, and it preserves it. So it's a way of extending shelf life and doing different fun stuff like that. So I really think that in the next 10 or 20 years, it could be something that's utilized a lot more. I have a very bad outlook on where our food's going to come from in the next 20 or 30 years, and I actually think that it's coming true, which is a little bit scary. And that's why molecular gastronomy is going to become so prevalent. So we have so many different varieties of stuff that we can get now. I mean, you can walk in Whole Foods and get pretty much whatever you need. But imagine a society where we're only able to grow or produce 20 or 30 different things. We need a tomato to survive. We need rice to survive. We need protein to survive. Well, if we scale down the choices, then we only have 20 or 30 different ingredients, and we need to be able to change that into a whole wide array of different stuff. So that's why this is so interesting to me, is because we can take different products and just manipulate them and do really, really fun stuff with it, like Cheetos. So Cheetos actually have the best structure for liquid nitrogen. Cheetos are about 80% air, and what happens is the liquid nitrogen, it gets trapped in that really good structure, and then it doesn't get released till it hits something warm. So what was the temperature of nitrogen? I'm going to make this interactive now, so you guys are going to have to deal with it. What's the temperature of nitrogen? Negative 320. What's the temperature of your body? 98 degrees. What's the difference? Yeah, it's too early for that. So it's over 400 degrees difference. So that's a really, really violent temperature change. And it's really awesome to me that we can demonstrate this, that we're talking about temperatures of space, and we're talking about temperatures of Earth, and we can actually put it all in a bowl and demonstrate it. So the nitrogen's been sitting in there. The Cheetos have been sitting in the nitrogen for a little bit. So we're going to pass these out. The only warning I'm going to give to you is don't put the whole Cheeto in your mouth or you'll explode. You just want to take real little tiny bites. I've seen a kid explode before. It's pretty funny. I'm going to burn your tongues a little bit when I do this too. Your taste buds grow back. They actually grow back better than what they did before. So I always have that as a nice disclaimer as we're doing stuff. So kind of to wind up everything, bravery is what we kind of all strive to do. That's kind of, when they told me to do this and they told me there was going to be all these creative professionals in the room, I thought it was going to be really cool, because we're all brave in our own, sense. We kind of put ourselves out there, and we expect everybody to enjoy what our vision is, and sometimes it just doesn't happen that way. And like I said, I work in a great field where it's, I can put it out, I can see if people like it, and then I can make little modifications and change it and do different stuff. I'll never not do Cheetos, because, Cheetos, like I said, the smoke coming out of people's mouth is what people want these days. When we all go out to eat, we love great service, We like the waiter to come over and say, is this a great move or great food? We like when the food is cooked properly and it's edible. That's kind of a big thing these days. But we also want the entertainment value. I say, and I tell people a lot of times that Food Network has killed my industry because everybody thinks that they can cook. They think that, it's just kind of like this little, and they're running around and having fun, and it's really hard because your magnets fall all the time. But I tell people, like only 1% of the population probably could become an executive chef. And maybe 1% of those people actually, strive and do really well. And then 1% of those people are actually open, in 4 or 5 years. So it's the vision, it's having everybody see your vision, and it's continuing to create and innovate and do fun stuff. So, with my thing, it's never stopping. I'm building a boom right now where I'm actually going to make it snow flavors. So imagine walking into my restaurant and you put your head up and you catch creme brulee snow in your mouth or foie gras snow or something like that. Sounds easy, right? But you got to think about how crystals are made and how it comes out of the boom. And I want the snow to be snow right here, but if it falls another 2 feet, I want it to dissolve because I don't want a big pile of snow on the ground and people slipping and doing everything like that. You might come into my restaurant with a white suit on. I don't know why you would wear a white suit, but so I don't want that snow to have color in it because it would stain your dress or it would stain your suit or anything like that. So these are, when people have ideas, sometimes you think it's just going to explode and be this great thing, and sometimes it's drawing board, and sometimes it never works out. I have things that I'm still working on 10 years later, but I've been very fortunate because I've been given these tools to kind of reinvent and, do some different stuff. And, I feel very blessed to be able to give people experiences. That's what I do on a daily basis is, I get to do somebody's wedding, and they remember that wedding and they remember the food and they remember the smoke coming out of their mouth and all that other kind of fun stuff. So I feel very fortunate to be a creative professional, and I feel very fortunate to be, part of an amazing community that we have here in Denver. So I wore goggles today. I didn't even turn them around. So I'll hand out Cheetos with goggles on, I guess. So I guess I'm going to hand some Cheetos out, and we're going to do some Q&A for a little bit.
Sure.
Okay. So I'm pretty portable here. I was told not to walk past that speaker, though. All right, so what's the rule on the Cheetos? Small bites. All right, if guys have any questions, okay, go ahead.
I've never purchased liquid nitrogen.
Okay. So what's really expensive with liquid nitrogen is the storage. So that dewar that I have, I bought it new for about $2,800. You can buy used dewars on eBay, but some of those have been used in the medical industry, and some of them, might not be the cleanest thing in the world. So when it comes down to it, liquid nitrogen's about 2 cents an ounce. So it's not really expensive, but like I said, it's the storage, and then the other big thing is training. You don't want to give your dishwasher a big tank of liquid nitrogen if he's never seen it before. So for me, it's all about, making sure that people have the right knowledge to be able to use it. I tell people nitrogen's just like fryer oil. So you wouldn't take a big swig of fryer oil. You don't take a big swig of liquid nitrogen either, so.
You put your hand in there without protected? Did I see you?
Yeah.
Minus 320?
Yeah. So you're not supposed to put your hands in it. But if you put your hands really, really quick in it and come out, it won't burn you. It's when it actually pools on your skin. Because what it does is it's evaporating all of the moisture. And when that moisture is gone is when it really starts to burn you. So if anybody's had frostbite before, it's frostbite just, happening within seconds.
How long will that Cheeto stay frozen like that?
So the Cheetos, like I said, are a real good consistency. They'll stay cold for about a minute and a half. We do popcorn. So popcorn's only really, really cold for, about 35. Why is everybody laughing at me? For about 35 seconds. So you guys have to, if you're passing up a Cheeto, you got to try it. All right, who else has questions? I can't see anybody in my goggles, so. Yeah, go ahead. It doesn't. All we're doing is we're just making stuff really, really cold. But you'll see like news stories and stuff sometimes of like people having to go to the hospital because they've ingested liquid nitrogen, and you cannot ingest the liquid part of it because what happens, like I said, it's expanding at 2,000 times its volume per second. So what it does is it'll burn the trachea on the way down, and then if it sits in the stomach, so everybody have a Cheeto while I'm explaining why you're gonna die when you eat a Cheeto. Great question. Small bites.
So did you have any kind of happy accidents that have led to things that you've gone on?
I've had a lot of happy accidents. That's a great way to put it. I'm gonna start using happy accidents. So I tell people that literally I would serve probably 10% of the stuff that I would make to the general public. A lot of it's really, really, really bad, and I think that's why molecular gastronomy gets a bad rap sometimes, is because people are they're using it and they're putting out just to be able to put it out, and that's not what it's for. It's a tool just like anything else, and if you're not doing great stuff, then why serve it to the public? So the best story I have for that is I was trying to make soda once, so I made like a yuzu syrup, and I put it in one of the whipped cream canisters, and I put a charge on it. So I came in the next morning and I thought, this is gonna be the best soda, because I've let it sit overnight. So I hit the little handle and nothing came out. So I was like devastated. I was like, I'm just gonna throw this away. But then I opened up the canister, and what happened is the yuzu had congealed into a jelly, and then it carbonated with the nitrates that I put on it. So I'd made carbonated yuzu jelly. So I put that on top of an oyster, and it was like the best thing that I've ever had. So when you screw up, you have to take it to the nth degree. You have to ask the questions, why did this happen? Because if you don't learn any lessons. And the other thing that I really would like to stress is you have to write things down. I make a lot of recipes, and then I get to the end, and I'm like, this is the coolest thing that I've ever done. How the hell did I just do that? So it's a matter of kind of documentation. And this bowl is cold and making sure that you know how you got from point A to point B. Anybody else? Cheetos? Any other questions for me?
You were talking about being a little concerned about where food's going to be coming from in the future, but you also mentioned that a lot of the stuff that you're doing with molecular gastronomy has been available to processing services for a while, which I was just wondering about. Like, I usually think of processing as maybe being part of the problematic aspect of where food's coming from.
Right.
So I was wondering your thoughts about what stuff you're working on, how that's going to work out.
Yeah, and it's, I think I froze my coat. So the questions about additives and the stuff that we use and if they're natural and stuff like that. So I did a lot of research because, when you're starting out with new things and there's not a lot of people to answer questions for you, you unfortunately have to come up with the answer yourself. I had a friend that when I was first starting this stuff, he told me, fake it till you make it. And I think people say that a lot of times. That works until somebody asks you how to do it. And then you're like, you can't fake it anymore. You really have to understand from point A to point B to point C. So, you know, that theory just doesn't work very well. So when I have a lot of people go and ask me, you know, why are you manipulating food and changing and stuff like this? Well, I only use natural products. Carrageenans come from seaweed. Agar has been used in the Orient for the last 3,000 years. You know, VersaWhip comes from the root of a tree. You know, I use all of these stuffs that are natural products, and I buy them from reputable sources. That's the other important thing. You know, you don't buy baby formula from China right now. We all know that. You don't buy these chemicals from, you know, a source that, you know, is putting in stuff that shouldn't be there. So it's diligency. It's, you know, making sure that you're doing the right thing. You know, I'm a chef first and foremost. So, you know, I make sure that I'm checking out the Monterey Bay Aquarium website and, you know, only using, you know, fish that's, you know, sustainable. You know, it's all the stuff that we all are responsible for doing right now. Unfortunately, you know, I think I'm thinking we're taking this almost too far right now. It's kind of scary. You know, I think about my children and if they want to be chefs and what products they're going to have to use and if they're going to have the freedoms, you know, that we have these days. So, frankly, it's scary as hell for me. I'm enjoying what I get to do, but, you know, we all have to be proactive and, you know, understand where our food's coming from. You know, that's a huge thing right now is just everything is just mass produced. We're away from the family farms. You know, when I was a kid, I'd go spend time on my grandparents' farm. We just don't have that anymore. So yeah, it's a little bit scary, but you know, at the same point, you know, it's the individual's responsibility to make sure they're doing the right thing. So probably talked way too long.